Hey guys and gals. Hey guys and gals. How you doing? Welcome back. Welcome back. Thank you so much. So much for hitting that play button. Let's go. You know I love that. That's awesome of you. Let's go. You guys are great. You guys are truly great. Great to this. Full of greatness. Turning you guys up a little bit. It's awesome to have you here. Truly is. Let's get into this, okay? Usual stuff I mentioned at the beginning of every video. Parents, homeschooling parents. Those of you that are homeschooling your children, here to help. That's what the channel here is doing. Here to support you in mathematics. I guess I really didn't explain grade 9 and higher, I guess. I guess it doesn't really matter what level. Mathematics. Math is math. We're doing from the basics anyways, so it could be any level, to be honest. So anyways, here to help. Assuming that you have lots on your plate, as it is. Probably overwhelming, so I would like to help you out. Just take note that over here we're staying on topic, staying focused, and we're teaching just math over here. Mathematics. That's right, staying on topic. Any of you students looking for additional help and support, you are welcome here as well. 100% you are welcome. If you have any particular area in mathematics that you're working on and I need assistance and help with, just let me know down below in comments. I'll do a video or a series of videos just for you if need be. Yeah, that's it. It's great to have you here. Pumping you up. Let's get excited. Let's do math. I love math. I truly do. Bit warm over here today, so I don't know. Doing videos a little earlier today, but it just got to get into the teaching mode and doing streaming mode. I guess could be my problem. Need to be consistent with the streaming, so I'm gonna try my best to be consistent and do some more videos for you. We got lots to do, lots of areas and chapters and sections to cover, so I better start getting myself in another gear and let's get to work. All right. Yeah, let's do this. Okay, so the area that we're working on, Unit 1, I guess, we're rolling with it. Pricing, currency exchange, we're doing lots of different things here. Talking about what you can do when you're shopping, comparing in that. Hopefully I corrected that when we were working on a last video. It felt like maybe I was getting little off topic with it. I wasn't really getting off topic, but just doing different things that wasn't really necessary. So I'm kind of kicking myself in the butt a little bit. But by the time we got to the end of the video, we've got it all organized in our head. Hopefully it's better and we understand what we need to do when we're out shopping. So that's great. Now we're working on fractions. I guess we'll be working with decimals. We'll be working with more fractions. Fractions aren't so bad, guys and gals, okay? They really aren't. Just think of it as a number over a line with another number underneath that line. It's really all it is. When you're multiplying and dividing fractions, it's really super simple. Truly is. Fractions are just straight multiply numerator, straight multiply denominator. All right. Probably one video, maybe I'll just do on fractions, another video on decimals sometime. When I'm working out problems and that, I usually show all the work, all the steps. And I try to explain it without over explaining it. I'm a work in progress, guys, so please bear with me. I'm one of those guys that I'm a doer. I could do it. It's just a matter of teaching it and explaining it. It's kind of another thing. So I'm working on that, slowly improving. Thank you for understanding and being here. Let's do this. So what is so percentages? Like when we're working on, I don't know, percentages. Let's say you have an exam, right? It could be anything you want to percentage of something. Maybe, I don't know, you have so many candies and a bag of candies has, I don't know, maybe you only have 14 candies left. Okay? And the bag initially contained, I don't know, 98, right? You want to kind of figure out how many you have left. How much do you have left in a percentage? Okay? Let's do a quick definition of a percentage. What is a percentage in math? Okay, or mathematics. In math, a percentage represents a number as a fraction of 100, right? So normally when we're working with percentages, it's out of 100 or 100%, right? So in other words, we take this fraction, which I should probably write it as a fraction, okay? Well, I'll just leave it like that. That's fine. So we turn a fraction into a decimal. So it turns into a decimal value. Whoops. Right? And then to get that into a percentage, we normally multiply it by 100. Okay? That's kind of the simple general way of doing it. Okay? Just like that. So, I guess you could, technically speaking, do the long division, which we don't really need to, but you would kind of set it up like that, right? 14 divided by 98. Okay, unless, did I get that backwards? I don't know. I might have got this backwards. Gotta kind of remember which goes inside, which one doesn't. Money was on the inside, right? Yeah, money was on the inside, if I remember right. Just from the last video, $1.08, $3.80 divided by 12, yeah. So normally when we set up our fraction, if we're doing the long division, the quantity would be outside. Okay, just to make things clearer. Okay, so in that case, I did have this backwards, so that means our divisor is outside. So just looking at this, I could already tell that we're going to have a leading zero. Okay, now we're not going to do any decimals like that, because that's a bit of work. Okay, so we'll just use our calculator. Now, I would understand that if your parent or your instructor or whatever, they really want you to, they want to know that you understand how to divide, right? Really, that's what they want you to be able to get you to understand. They want to see if you actually understand how to do all this long work, right? We've done enough examples of this on 24, 36. So that's 3, 36. I'm just ignoring the decimal. If you've been following along, you'll understand what I'm doing. 2, and bring down the 0. Up, 0. This goes into 20 once. So that's 12. I'm kind of running out of room here. So I would end up with 8. kind of have to borrow a 0. Let me just go like this. 12 divided by 3.8. Hang on, 3.8. I did that backwards on my calculator. There we go. 3.1. There we go. It is working out. So I can see it coming now here. So I gotta borrow a 0. I'm just putting a decimal here as a place filler, a temporary position for now. This isn't the final answer. As a matter of fact, I could figure it out right now. I could just move my decimal 2 jumps from here. At the point where you borrow a 0, where you're adding a 0, if you will, that's when you want to kind of just put a temporary decimal or just move it to here. Because that's actually where the decimal belongs, is right there. With that said, let's go 12 and 80. So how close can we get there? 12 times 6 gives us 72. Another 12 would take us to 84, right? 12 times 7, 84, which is over, right? So 12 times 6 is what we did. I didn't mean to add a 0 there. My bad. What I was talking about is the 0 here, and then you put the decimal. Okay, 12 times 6, right, gives us 72. And then I'm just going to put the 6 there. And then when I go 72, we get 8 again. So what's happening here, guys, is we pretty much end up with an infinite situation. This is how you get repeating. So now I got to borrow a 0 again. Same thing, 6, 72, and it goes on and on and on and on. Essentially, it's never ending. So a lot of times you'll see your calculator with a 7. Weird, right? So that just means that's kind of stop. We stop there. We're not going to write 10,000 6s, right? We're just not. So we stop here. And I believe you could represent it with just a line like that, showing as repeating. Okay, just so you understand what happened, I took that from down there and put it up here, just to continue it on. Okay, that's kind of the long work. So we end up with that, but again, it's 2 decimal jumps. So we go 1, 2, the decimal's actually there. And our answer is 0.316, blah, 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 repeating. So once we multiply that by 100, essentially, we're moving the decimal back. We're going to get 31.67%. Okay, that's going to be our answer, right, in a percentage form. Whenever you multiply by 100 or divide, so if you divide by 100, the decimals jump twice to the left. If you multiply by 100, the decimal jumps to the right. 2 jumps. You count how many zeros you have. That's how it works. If I'm multiplying by 1,000%, well, I'm going to do 3 jumps. That's how I look at it. However many zeros you have. Okay? So I didn't mean to go into that long division. That's fine. Good for practice. You're probably like, oh yeah, I remember all that stuff. Right? I won't lie, a little bit rusty at doing it myself, but doing okay considering, right? Quick coffee. So with that said, that last one we did, we pretty much have 31, 14 divided by 98. Did I do that wrong? I must have. Did I do that wrong? Hang on. Okay, it's too late now. Whoops, hang on. hold up. It's too late now. Oh man, am I having a bad day today? I don't know, guys. I really don't. I hope I didn't mess that up. I felt like we did 14 divided by 98. But now I'm like, what? I'm getting a different answer. That's okay. I can't rewind a live stream, so I can't go back. And of course, when I went backwards in my program here, I lost everything in memory. Let's just carry on. Another way of doing percentages is, I don't know, you could, if you're a visual person, maybe you are. I'm going to try to draw this kind of accurately. 1, 2, 3, 4. Okay. Actually, I don't know if that's where the line's going to be. What do I have? 5 by 5, right? 5 by 5. I'm just going to do a quick example. Okay. Try my best to draw here, guys. Bear with me. Okay, close enough, good enough. So we have 5 rows and 5 columns, okay? So to figure out this quickly, you don't need to count them, right, guys? It's just figure out how many rows, how many columns, go 5 times 5. And the answer is 25. So we have 5 squares. 25 squares, my bad. Okay, we have 25 of them. All right, so let's say all this was shaded, okay? I'm just gonna kind of, I don't know, it's not really gonna be best, but this is all shaded. Okay. Whoops. All right. So the question is, what percent is the shaded area over out of the total, right? So we have 2 rows shaded, 5 columns. So we have 2 times 5, which equals 10. So we have 10 shaded. This is just kind of as an example, okay, guys? 10 shaded out of how many? Total, right? This is total. What percent shaded is it compared to the total, right? So that's out of 25. And I could quickly reduce this. We're dividing both numerator, denominator. No, we're factoring 5 out of both. 5's our common number, meat off the bone. Hopefully you've been following and understand what I mean. We basically have 2/5, okay, essentially. Or we could turn that to make it easy, because we do everything out of 100, right? When we're working with percentages, you can actually have a rough idea in your head. So we want to make this 10, right? So we're going to times it by 2, times by 2. This is multiplying with fractions 101, guys. Multiply the numerator, multiply the denominator. It's straight multiply. So there we go. So now we have a 10, which is, right, we could add another 0. Boom, boom. We have our 100. So it's 40 out of 100. That's without using a calculator. And then we could cancel this, which would give us 4 out of 10. It's all the same. Okay, you still get the same number. Same decimal value, which should be 2 jumps. Yeah, 0.40. Okay, in decimal form. And that's what it is. So another way to do this, right, that's just one way. Again, there's kind of different ways to do this. It just depends on what you prefer more when you're working out problems. Okay, there's things that you could do to help you kind of logically in your head go, okay, this is what my answer should be, right? It helps to have that kind of general idea what your answer is going to be. The way I did that, right, you understand what I did here? Because I know it's out of 100%, right? I wanted a 0. I wanted a 10 or a 0. It doesn't matter what I just want a 0. A 1 and a 0. That's what I want. So I multiplied the top by 2, and then multiplied 5 by 2. 5 times 2 is 10, right? So it gave me a 10. So I ended up with 4 out of 10. And to get it into 100%, well, I just added another 0. I just put it there. I just went, okay, here you go. Boink. Placed it there. And that gave me 40 out of 100. Okay, so I know that my answer, because just like I was saying before, when you divide by 100, you do the decimal jumps to the left. Okay, that's divide. But when you're multiplying, it's to the right. 1, 2. 1, 2. That's what I mean. To take it to a decimal, you're going from right to left. To go to percentage, you're going left to right. If you could kind of remember that little tip. All right. So there's our answer without using the calculator. So there we go. Let's just drop in the yays for fun because we haven't done that lately. So again, percentages, it's often expressed with the symbol percent, right? Like 25% means 25 out of 100. Essentially, that's what it does mean. So if I write 25%, it's just like I was saying, guys, right? We know percentages are out of 100, right? Anytime you hear percent, think out of 100. So I could actually go put the 25 here. Actually, I'm going to move it further so we could go a little bit further, show the work. So that's a quarter. I always think of 25 as a quarter. It really is. What's 25 cents? That's 0.25, right? It takes 4 of them to make $1, which would give us 1.00, right? 0.25 times 4 gives us 1. Okay, it's no different. Like I said before, if you've been watching, numbers are very repetitive. right? You could ignore decimals and just go, like if you have the number 0.25, you could ignore the decimal and just think 25, right? The decimal is just a position and it has a different meaning, right? This means a quarter essentially. 25 is a whole number. The decimal would be there, so 25 could mean anything, a quantity, whatever. So we could actually, at this point, factor, right? Let's do some fraction factoring. How do we get 1/4? Well, let's find the most meat off the bone. The most meat off the bone is actually going to be 25. Because, like, you could do it in parts if you're not sure, right? Again, you can study your times table. All right, it helps. Count by fives: 5, 10, 15, 20. It's 5, 0, 5, 0, 5, 0, 5, 0. That's the pattern. Numbers are patterns as well. Let's say you don't know. So we could, the most meat off the bone, let's say you start off with 5. Okay? It doesn't matter. It's okay. You could break it down twice. Okay? 5 times 5 is 25. We're just taking that 25 and turning it into two numbers. That's all we're doing. But we need a common number so we can cancel each other out. We need a common number on the numerator and a common number on the denominator. They both have to divide into the numerator and the denominator so that we get a value of 1. Anything times 1 or divided by 1, same answer. Unchanged, right? So at this point we got to figure out, well, what times 5 gives us 100. Okay. So we have 5, so we could look at it like this. How do we look at it? We know 2 5s gives us 10. Let's say we're plussing. Hang on, let me write that better. Terrible. 5 plus 5. So that's 2 5s. So we're going to need a lot more. We're going to need 10 of them at least. So we could kind of think of it in parts like this, if you're not sure. Another 2 5s gives me 20. Another 2 5s gives me 30. And we could continue on and on, right? But that's going to be a little time consuming to do it that way. That's one way of doing it. Or we could just start, I don't know, kind of guessing. What's 10 times 5? Let's do that, right? Let's guess some numbers, okay? We're going to say 5 tens. Okay, what does that give us? That's 0. Anything times 0 is 0. And that's 5. Okay, so that's obvious, right? 10. If you have $10, you could think of it, look at values, whole numbers. You can look at it as money if it's easier for you. If you have 5 tens, you're going to have $50, right? But we're going all the way to 100, so that's double. If you understand quarters, 2 quarters equal, 2 quarters equals 50 cents. Another 2 quarters equals 50 cents. So that's 4 times 0.25. We get 1, right? So therefore that means $10 times 10. What's 10 times 10? Right? It's going to be double. We're just doubling the 10 here. 0, 0, place filler, 0 and 1. Okay, we get 100. So with that said, is that what we need? No, because we need 5. So how do we figure this out? I know I'm kind of making it like, well, I'm just trying to throw out different ways where you could just brainstorm to figure out a number. That's what we're doing here, guys. Okay? I could straight just write the number. I could. But we're trying to figure it out, right? Logically. How else do we do this then? Okay, well, 10 times 5 gave us 50. And 10 times 10 gave us 100. It's not really what I want, though, because I have this 5 here. I need something times 5. Oh, that's how I could do it. There, I'm figuring it out now, guys. Okay, let me show you. Okay, so if 10 times 5 is 50, well, I need 100. Right? So instead of doubling the 5, because we need the 5, right? We need that 5. We don't want to change that. Let's double this. Let's double that. Okay, let's do that. 20 times 5. 0. I'm just doing it like we're beginners. You know, that's what I'm doing here. 5 times 2 is 10. Oh, there we go. There's my answer. 20 times 5 is 10. I'm 100, sorry. Okay, you see? That's kind of like brainstorming to figure out that number. Alright, there we go. But it's still not enough. So we're left with 5 over 20, but we still haven't reduced far enough. We could go a little bit further still. Okay, this is kind of fractions class a little bit. So that means, okay, well, I want to make my numerator 1. So to do that, we're going to pull out 5. Okay? What times 5 gives us 5? Well, that's 1, right? And then we're going to do the same thing. Pull out 5. This is the meat off the bone number, because I want these to cancel each other out. So what times 5 gives us 20? It's 4, right? So we're left with 1/4. And basically, guys, gals, excuse me, I just had some coffee. That's how you take a fraction like this and reduce it. Okay? This is called reducing. I'm doing this because a lot of people, I think, have a real huge difficulty with fractions. And I'm trying my best to kind of keep it simple, simplify it so it's easy to understand. Okay, and that's what we want. So we reduced it from 25 over 100 to 1/4. All right, and that's how you do it. So what I've done here, I guess I could leave all that, it doesn't matter. So what I've done here in this step is called factoring. Another way you can look at it is taking the most meat off the bone. I know it's kind of like, I don't know. It's just the analogy I use. The most meat off the bone is the number that you want to find, the largest number to reduce a fraction. And as a matter of fact, that number was 25. If you look here, you can see these two numbers are the numbers that we factored with, 5 and 5. What's 5 times 5? 25. Okay, that's the actual meat off the bone number we should have used right from the get-go. But I wanted to show you guys and gals, it's okay to reduce twice. If you don't find that big magic number initially, that's fine, it's okay. You'll get to this point here, and you'll look at it and you go, I can still reduce, right? All right, hopefully that helps. That's kind of reducing and factoring 101 right there for you. Working with percentages. Again, it's all fractions too, right, guys, gals? Okay, this is easy. I'm gonna try to keep it generalized. All right, I'm gonna do my best. What is 80% of 20? Okay, let's say so we're kind of going the other way. So hopefully you've been following and you know what ratio proportion is. I really hope you have been, because I try my best to go through a lot of examples. Ratio proportion. I totally spelled that wrong. Proportion. Myself, I'm pretty decent at spelling. I'm pretty decent at figuring out which your and which your to use in the sentence. Okay, I have no problems doing that kind of stuff. There and all those sort of things. Making grammatically correct sentences. Pretty decent at that. But I'll tell you, I can't write an essay to save my life. I cannot. I have no problems admitting to that. Some people, you know, they're just better at writing. The way I look at it is, if you're really good at writing, you're probably not good at math. Okay? Just being real, right? A realist. I mean, you could probably do math, but that doesn't mean you're university level math major, right? You're probably a university level English major, right? For example. And it's the same thing, vice versa, right? That's okay. We all have our strengths and weaknesses. That's just humans. All right, so the question is, what is 80%? What is 80% of 20? And it's like, oh my goodness, how do you figure that out, right? I guess if you're a visual person, you could draw yourself a diagram, right? Some people are visual learners. Whoops, I need another row. Right? That's another way of figuring it out. There's always a way of solving a problem. Okay. Do I have 20? No, I don't. So what I'm going to do is add another row. Okay. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay? 4 times 5 equals 20. Okay? I'm just going to do it like this. This is just for a visual. Okay? Again, some people are probably, you know, there's people learn visually. There's people that learn just by listening. And then there's people that learn by seeing. Right? Visual. Touching, by touch is another way, but how do you do it with math? How do you touch, right? Like, for example, if, let's say you're into electronics or something, in order to learn about it, you have to pull it apart, take it apart. That's by touch, learning by touch. In a sense, you're learning visually as well. Okay, so this is visual learning, right? Give yourself a little diagram, pictogram, whatever you want to call it. And it's 80%. So that means majority of it's going to be colored in. So how do we figure that out? 80%. Do we cover up 16 out of 20? Would it work that way? 16 out of 20? So if I covered all of this from here all the way to here, that's 16 out of 20, right? Does it work the other way? I think so. I think it would. Let's see if we do it like this. Does that work the same way? Maybe, maybe not. Hard to say. I think we might be on the right track going this way, but let's see. So that's 1, 2, 3, 4, 5. 5 times 3 is 15. So that's 15 out of 20. Okay, that looks like, just from experience, right? This is ending in 0, right? How do I explain this? This has a 5, so I would think this might turn out to be 75%. I'm just guessing. I'd have to work it out. The way to work it out is to do it like this. Remember how I was showing you earlier? Let's turn this number into 100, right? So what times 20 gives us 100? What times 20 gives us 100? 5 of them, right? So, just like math is like one of those things when you're working with fractions. What you do to the denominator, you also have to do to the numerator. That's the nice easy thing about fractions and multiplying, or multiplying with fractions. So simple. Now, I could do the long multiplication because it's really simple, quick math. 2, and there we go. I am getting that 75. So that's 75 out of 100. Okay, so that's not correct. Okay, so it's not 15 out of 20. This is just working the problem, guys. That's what we're doing. We're trying to figure it out, and we're using our noggin. Okay? Figuring it out without being lazy and relying on a calculator. You're not really learning that way. It's just going to be real. Okay? So there, cool. Let's do 16 out of 20. Let's see if that's it, right? We covered all of this, remember? Instead. Sorry, I don't mean to make it messy, but that's what we did. Okay? So same thing. What times 20 gives us 100? Remember, it's out of 100% to figure it out. Okay, so we multiply 20 times 5, right? 20 times 5 is 100, right? What we do to the denominator, we also have to do to the numerator as well. I love multiplying fractions. It's just it's so easy. So this is 100. Now we have to figure out what 16 times 5 is. Okay? 6 and 5 is 30, right? Guys, you should have your times table memorized. Okay? Again, you can snipping tool this and print it out if you'd like. Save you some time. Whoops, I didn't mean to close it. So here we go. You guys could pick and choose which method you like best. Okay? This is one way of doing it. Let me show you another way. Okay? Let's work the problem. So now we're taking it from a visual. That I did that for the visual learners, okay? You still have to do a little writing. But here's another way of doing it. Remember I mentioned ratio proportion? I know I mentioned it earlier. We're doing that now, okay? So you got to set up your fraction, right? You set up your fraction. Setup is key for ratio proportion. Okay, remember it's out of 100. Or recall. So go 80 out of 100. This is probably the quickest way, right? If you understand how it works out visually, what we just did, once you understand that, then you could just go straight to doing it like this. Ratio proportion. So there's our setup. 80 out of 100. Out of 20. 20 is going to be our bottom number because it's a percentage of 20. So we're going to have a smaller value. So what is the percentage? We'll just use P. Good enough. Any variable, it doesn't matter. Okay, there's our setup for ratio proportion. This is a step I always teach my kid. Cross multiply. Okay. Cross multiply. And then the next step, that's step 1, step 2, is to make everything in line or linear. Linear means straight line. So what I mean is we're going to cross multiply to do that. So 100 times P. I always like my variables on the left side. It's just I'm kind of consistent that way. If you want it on the other side, that's up to you. Okay, in line, making everything linear in line. 100p and then 80 times 20. So another way of looking at this is left-hand side equals right-hand side. You can look at it that way as well. Okay, step 1, cross multiply. Make left-hand side equal right-hand side. Left-hand side equals right-hand side. And now we got to isolate P, right? We want P to be 1, right? So that means we got to get rid of the 100. Some teachers will teach this where you just divide both sides by 100. You can, that works. Okay, a little extra writing, a little bit more messier. If you understand the steps here, right, the hundreds will cancel. If you understand what's happening here, you can skip all that. This is where I teach my son the third step is mathematics is like a teeter-totter. It's like a balancing act. Okay? It's not the best teeter-totter, but we'll just try to draw it. Okay? Hopefully you know what a teeter-totter is. Okay? So if you're adding on one side, this is the equal sign right here, guys. Okay? Equal sign. It looks like I'm drawing some electronic drafting here. Okay. What you do to the left side, if it's positive on the left, it's going to be negative on the right. So if you take a value from the left side to the right side, you change the sign. Okay, that's what's happening. Okay, that's Algebra 101 right there for you. So what I'm doing is I'm essentially taking the 100 from this side and moving it to this side. It goes from a multiply to a divide. That's it in a nutshell. If you remember that, all you really need to do is, I'm just going to undo all that, is take the 100, go P. I'll just write it here. This is all our numerator here, guys. Remember, that's our numerator. Technically speaking, this is still all over 1. Okay? 80 times 20 all over 100. Okay, there we go. P is now 1. Okay, I have to kind of clean this up so I could do the actual math. Okay. I will repeat and kind of repeat myself a lot, but the way I look at it, repetition, repetition, repetition. Okay. Now, I could actually factor and reduce here right now. I like to do that ahead of time. You're gonna have to do it in the end game anyways. So it's easier to kind of just reduce right at the get-go. So I could cancel a 0 here right now. Again, if you cancel 1 0 here, you cancel 1 0 here. So what I'm left with is 80. You can do this stuff. Trust me, it works. It still works out. You're left with that. 80 times 2. Okay? We could do it again in another step. As long as it's numerator over denominator. You can only do this. I was showing this in one video. I thought maybe I could kind of shortcut and reduce ahead of time. You can't reduce here. That's a no. You have to wait until it's in fraction form before you can do that, okay? Never factor or reduce in the beginning. I guess you could do it here. I could have did it here because it's in a fraction. That's the only time you could do it, okay, guys? As a heads up. So as you can see here, I could actually do it again one more time. Cancel this 0. So now I'm left with a 1 for a denominator. So here we go. 8 times 2 all over 1. Can you see all the work that I'm doing? You can do this, right? If you understand the factoring and the meat off the bone stuff, like I've been showing you, right? If you understand all this here, you'll know what's happening here. I'm just kind of saving all those extra steps, right? I could factor and show you the work. I could do it that way, but I also know that I could just cancel zeros and still it would work out. So we're left with 16. There we go, done. Drop the A's. Some areas of math I'm better at than others, I won't lie. Like that shopping stuff, like I've done kind of that stuff when I'm out shopping, but it's not something I commonly do. Whenever I'm shopping, usually, you can't compare stuff. There's nothing wrong with doing that. It's probably good practice to do that. You could bring your calculator, you could do your comparison calculations and figure out which is the best deal based on that prior video we just did, right? Myself, I usually just kind of round things up. If I'm on a budget, I'll just, like if I grab a thing of shampoo for $3.94, I'll just round it to 4 and then I'll keep that number in my head. So using your brain is good, guys, right? That's what makes us awake and 120 IQ club people as well. Okay, welcome to the club, guys. Welcome to the club. Using the noggin. So so I'll grab items, and let's say my next item is a box of cereal for $5.84. I'll just round it to 6. Then I'll take the 4 and I'll add 6, so I'm at 10. So I have an idea, roughly kind of idea where I'm at for spending. let's say you only have a $200 budget. You have to be underneath that value if you're going to factor in tax, right? Anyways. So there we go. That was a little bit long, okay? But that's it in a nutshell. And that's the answer, 16. We did it 2 different ways, guys. Again, I'm staying on topic over here, so therefore equals I'm more qualified than the fake instructor that thinks they're, they have that diploma or degree or teaching degree or whatever. At least I'm teaching the math. I'm not teaching anything else. All right. What do we have for time? Yeah, we're up there. Boy, time flies when you're having fun. Okay, I'm going to leave. We'll just do one more quickly. I'll try to be quick. 36%. Write that as a decimal. Wow, how do we do that? How do we do that? Okay. This is kind of the way I guess I would do it. There's probably a mathematical way of doing it. Maybe I'll figure it out here on the fly. But I like to teach you guys the decimal jumping. So if you're dividing the decimal, trying to give you some diagrams here. These are zeros. Decimal jump, right, is to the left. Okay? And if you're multiplying, you're taking a decimal from the left to the right. Okay, so it ends up right there. Essentially, that's what's happening. Hey, what? Chat disconnected. That's weird. Okay, that was a minute ago. That was odd. Well, I don't care. Chat isn't busy anyways. Okay, so that's kind of how I teach it. Or you could go, I guess you could go like this. And then we could turn this into a fraction if we're reducing, right? I know that if I factor 2, let's see, what else could I use? 4 would be a good number. Most meat off the bone number. I'm just looking at OBS Studio here and it's saying chat disconnected. Please wait until we try to reconnect you, and then it's successfully connected. I mean, if you don't have lots of money to throw at YouTube, they don't seem to be concerned about you or me myself, right? They don't really share my content much, but as far as I'm concerned, it's a learning channel, man. I don't want to get off topic. All right, so times 4. So I know it's 4 quarters to make a 1, right? I know 4 quarters equals 1, right? Okay, if I add them all up, that's 1.0. Okay? I look at this as no different than being 100. The only thing that's different is the decimals in a different spot. I could still look at this as 100. Okay, I'm trying to help you guys understand logically in your head, right? If you ignore the decimals, I could add 25 4 times if these were whole numbers. I would still get 100, right? That's how I figure it out. So factoring, what times 4 gives us 36? Right? That's 9. So I'm left, so these cancel. I'm left with 9 divided by 25. I think that's as low as we can go. So I'm going to go like this. It doesn't really give us a decimal value yet, right? The only other way to do this is do it like this by doing the long division. Now let me see if I can get this right. So when we're doing currency, I gotta not mess this up. I have to organize it in my head. If something's 380 out of 12, it's the denominator that goes on the outside. So that's 25. I do that just to help remind myself. And 9. So I'm just going to add some zeros here, just a couple, to figure this out. So 9 divided by 25, I have the answer. So 25 and then 9 is smaller than 25, so we're going to go to 90. I'm just ignoring this decimal. I'm repeating myself, guys. Repetition, repetition, repetition. Okay, so 3/4 is 4/4 for $1, so that means 3/4 is 75. We could do the long math. 25 times 3, right? 15, carry the 1. 6 plus 1 is 7. Okay? So I'm going to go 3 right here, and I'm going to put 75, right? If I go times 4, that's 1 at 100 is greater than 90, right? I'm looking at it as 100 is greater than 90, right? So we can't go 4. We can only do 3. Subtracting, that's 15. To show the work, I'm going to borrow from the 9, make this a 10. 10 take away 5 is 5, 8 take away 7 is 1. Bring down this. You understand? Hopefully you understand what I did there. To borrow from the 9, you got to make the 9 an 8, and you give that 1 to the 0. So the 0 becomes a 10. 10 take away 5 is 5. We have 8 here. 8 take away 7 is 1. Okay, so now I'm bringing the 0 down. Because 25 is greater than 15, we need that extra place. So now we have to figure out what gives us 150. Well, if you know 75 plus 75 is what, right? So if you break it apart, 75 is 50 and 25, right? This other one is 50 and 25. Okay, so if I go 50 plus 50, that's 100. We know that 25 and 25 is 50. Oh, that must mean this is 150. I just broke the 75s into 50 and 25, 50 and 25. These are quick and easy. We could add in our head. We could go 25 and 25. We should know that 25, 2/4 makes 50 cents. It's the easiest way to look at it, which is 50. Okay? So that means 25 times 6, right? If 25 times 3 is 75, that must mean that 25 times 6 is 150. So I could do the long math if you'd like. 25, yeah, 25 times 6. This would be the other way to do it if you aren't sure, right? You could just do it like this. 6 and 2 is 12. 6 times 2 is 12. Plus 3 is 15. So 150. All right, I had to bring this down. 150 is here. That's what this one is. We're subtracting. This is 6. This goes there. Okay? And this becomes 0. That's what we want. Remainder of 0. So just like I've been showing you before, we have 2 decimal jumps, right? 1, 2. So 1, 2. Hang on, hold up. What am I doing here? Yeah. But we still have to multiply it by 100. So we're going to end up with 0.36. There's our decimal value right there. That's how you do it the long way. Okay, we can see it right there. It's no different, right? If I went 1, 2 jumps, we get 0.36. Now if I multiply by 100, we do 2 jumps to the right. So therefore our answer is going to be, well, our answer is up there. That's kind of right there, right? So there's our decimal value. Okay, I'm going to stop there. That's it, guys. Okay, answer 0.36. Showing the long work. I'm going to leave it at that. Thank you for watching. Thank you for being here. I'm going to grind up some more content for you guys and gals. Those of you that are watching, you're all awesome. You beautiful, intelligent, 120 IQ people. You guys are all, man, you guys are so great. You truly are. I'm going to leave it at that. My chat's doing weird stuff, but I really don't care, I guess. Or should I care? I don't know. That is it. I'll see you guys and gals in the next video. Whoever you are, wherever you are, take care for now. And Johnny Whiskey Tango Sharp. Much love. And peace.